Our next speaker is Sujit Sarkar, and he'll be talking about emergence of double frequency dual field Sine-Gordon field theory, a study from the perspective of quantumizing model.
Yeah, thank you. At first, I'd like to express my thanks to ICTS Statistical Physics organizer. And also, this is my affiliation, most probably the smallest research institute of India, even for the whole world. And this work has done under this project. Particularly, my special thanks or acknowledgement to the Library Ramanujan Research Institute. If I don't get help from this institute, my research will be reduced to the 1/3. Okay, and finally, the Cambridge University Press gone through some of my research paper, and they helped me through any books of quantum field theory. Okay, now the outline of my talk. Introduction, I will the basic physics of emergent phenomena, and then I'll say how the conformal symmetry emergent and the emergent of the conformal field theory, and the result mainly the correlated quantumizing model, and also as a consequence of that, how the strong correlation physics come and followed by the conclusions. Okay, this subject has started from this paper, and it is available in the online by Professor Phil Anderson. And also this paper is by the Oxford and Cambridge University seminar series. I was one of the speaker of it. Okay, the emergence of parity times symmetric critical phenomena appear here. And you kindly see how the Hermitian and the non-Hermitian quantum field theory, when I do the quantum field theory RG, how it is emergence, the different phenomena. Actually, the subject start by the Professor P.W. Anderson. Okay, in quantum any-body physics, emergent phenomena are in this view is fundamentally the two kind of phenomena emergent, which is the complex accessible particles which cannot be anticipated from a priori knowledge of the microscopic laws of physics. The behavior of the large and complex aggregation of the elementary particle cannot be understood in terms of simple extrapolation properties of the few articles. Okay, and then the emergent Laughlin and Pines, a book, a theory of everything, also just they appreciate the Phil Anderson's idea, and he gives some example from this physics like the superconductivity. Okay, now the question is this few example of emergent in other nature, whether I do the field theory calculation or not, you see the sand ripples are here, that is the water and also the Northern University and also the water crystal forming in the glass. This emergent phenomena is appears in the biology, also the chemistry, different parts of the quantum physics and quantum any particle theory. But here, my main perspective is this emergent phenomena from the perspective of quantum field theories, especially the how the correlation appear as a perspective of mathematical physics. Okay, now the renumeration group is an emergent property. Okay, it has been known since early 1970s. The renumeration is an emergent property of the ordinary matter, either in the stable quantum phase such as a superconducting state, or at the particular zero temperature phase transitions or quantum critical points or I. In this paper, one of my PhD student, now the faculty member of any university or college in this audience, he is also in the author. I show explicitly how in the different scale, either the non-Hermitian or the Hermitian physics, how the emergent phenomena appear. Okay, that is the renumeration group and the university class of fixed point. If we consider a fixed point of divergence correlation length, then one can ignore the short range correlation length. And that is the emergent class is the symmetry class emergent at a type, it called the scale invariance. And also a larger symmetry class appear, it's called the conformal invariance. Okay. Now I go to the point that the emergent of the conformal field theory, a general result of the Polchinski. Okay, Polchinski and also later of the Polyakov. Okay, earlier. Sorry, in this section we discuss the general properties of scaling as a QFT. a fixed point with a divergent correlation length at which the theory scale and the rotational symmetry invariant. From a microscopic point of view, a conformal invariance at the emergence symmetry of this fixed point. This general result of the Olchinski show that the scale invariant theory such as a much larger scale, conformal scale. And the conformal field theory, I have some work in the conformal field theory. In my view, this is the most beautiful, at the same time, the most hard branch of mathematics of statistical field theory. Okay, now the thing is this emergence from the perspective of the RG. I have already told you, because as the correlation is yield up, then the particle not will be no more the air particle, it became the trace particle, that is the electronic charge on the small scale. Suppose like an example is not in the electronic charge on the sufficient round scale. So this is the case I can, very few words on the Ising model. I'm doing it is from the perspective of the quantum Ising model. In the Ising derived 1920 doctoral supervisor, and the transfer matrix approach he has thought, but he has not found any transition without any field. So the thing is as the transition disorder 2D, then it's find the transition. Now the question is, the main question here was either the Ising model has no phase transition. I raised the question, if the strongly correlated Ising model has any phase transition. Yes, but this is not the conventional phase transition. This is the topological quantum phase transition. If you see the last year talk, which I have even in the ICTS, I have shown it explicitly. But again and again, the pupil and the referee asking me the question, how the strong correlation appear. So this is the reason this year I can give the detailed quantum field theory calculation of the strong correlation. This is my model Hamiltonian quantumizing model. After the Jordan-Wigner transformation, I transferred this spin model Hamiltonian to the spinless Fermat model Hamiltonian. Lambda 1 is my coupling and U is the transverse field. Now I want to the mathematical preliminaries, my quantum field theory calculation. If I get the dispersion, a short cutoff across the two Fermi points, and this is the dispersion, I can write the epsilon k. And if I do the cutoff infinity, I can extend this linear across to this point in that case. So in that case, I can write the Hamiltonian in this form and the Lagrangian in this form. Here you mind it, the spin annihilation and creation operator is no more. Now it is in terms of the field. I can write the right field and left field. This is the Dirac Hamiltonian, and also this is the momentum Lagrangian. That is the energy dispersion for the different values of mu and lambda, and also at this case. Now at the detailed quantum field theory, I express only 1 or 2 minutes. This is, I can express my field in terms of right mover and left mover field. And the elementary excitation of the system, I can express in terms of the bosonic field, the right, and then this is the creation and operator. And these phi x and theta x are the dual operator to each other in terms of the left hand and the right hand phi coordinate, phi field. And so they are satisfying the following condition. After this, I can recast the spin Hamiltonian in terms of field and dual field. At the end of the day, I got my Hamiltonian here. That is the H naught, the kinetic energy term. This is the case, and this is the Sine-Gordon coupling term with a single frequency, and this is the Sine-Gordon coupling term, the double dual frequency. And K is the Artingel liquid parameter. I can express the K in terms of this. The physics of low dimension quantum many body condensed matter system is enriched, is new and interesting. K less than 1, K get at the characteristics, the repulsive, attractive interaction, and the non-interacting. In the correlated quantum any-body physics, this situation is described the celebrated Sine-Gordon model, which is also play a central role in quantum field theory. Conclusion, we have introduced the physics of emergent explicitly. We have introduced the model Hamiltonian. We have derived and presented the dual field, double frequency Sine-Gordon model Hamiltonian. We have explained the physics explicitly emergent, not the gens, of strongly correlated in our model Hamiltonian system. Thank you for your all kind attention. Any question, comments, I'm ready to face.
Questions from the audience? If not, then let's thank the speaker.